HCl by using a pH meter. So we are conducting a pH meter in this experiment by using a pH equal to minus log H plus. So this is the basic formula. We are converting the water samples to check the water sample whether it is an acidic or basic medium, or it can be a level of high alkalinity or high alkaline metals. So we have the by using this formula we can identify the liquid solution into as a whether it is pH that is less than 7 greater than 7. It can be classified by using this formula, that is pH equal to minus log H plus. So H plus is the constant H plus ion materials. So here in this experiment we are using to determine the strength of HCl by using pH meter. So we are going to determine the pH by the HCl solution. So for that we are taking as a urine solution of sodium hydroxide and pipette solution of HCl, and the instrument we are using as a pH meter, and the meter which is using as a pH, and the electrode we are using as a glass electrode, and the temperature we are using the same as in the room temperature, and the instrument is pH meter. So these are the basic procedures followed by using this experiment. Urine which should be filled by with the readings of 0 to 50 ml by using a sodium hydroxide, and from this beaker we are collecting a 20 ml of the HCl solution and 20 ml of distilled water to ionize the solution, and in this solution we are inserting the pH meter glass electrode into the solution and connecting to this pH meter to conduct the pH of the solution, and the temperature we are maintaining as a room temperature to follow these reactions. So whenever we are inserting the glass electrode into the solution, we have to check whether the clarity of this pH meter, which better it is condition of 0.4, that is 14. 14 is the pH value to indicate whether it is acid or basic medium, and we have to conduct the values throughout this experiment as same. So here next the procedures to identify the experiment is, first we are taking a pure solution with this at 50 ml, and the pipette solution we are taking as a 20 ml. To mix this solution we are using the glass rod, and with this solution to indicate the reaction we are adding glass electrode into this beaker, and we are checking the values into the pH meter whether, and again from the pure solution of sodium hydroxide from readings of 0, and again we are adding a 1 ml of the solution into this beaker, and while stirring the readings will be changes. Likewise the readings will be a light decreases and then increases by using this, and we can plot this graph by using a pH of first decreasing values and other increasing of values, and again the plot to second graph we are indicating by using this same as the increasing order of HCl and sodium hydroxide, and we are plotting the graph by using pH equal to volume of sodium hydroxide. So we are plotting the graph by using volume of sodium hydroxide and the pH for the first graph, and we are plotting the values by dot, and by adjusting the values we are pointing as a electrode. At the midpoint we are converting as a mid value of center value, and we are converting as a volume of sodium hydroxide value, and the second graph we are converting it into a del pH by V into volume of sodium hydroxide. So this is by converting the graph which have the volume sodium hydroxide is a 0, 1 to 20 ml of readings, and with this reading we are using this value of sodium hydroxide, and the value of del pH by del V we are calculating this value of, from this subtracting these two values we will get this del pH by del V by dividing, and we plotting by these two graphs we will get the curve graph, and we are plotting this by using the midpoint of the graph as a center point, and we taken as a volume of sodium hydroxide from this second graph. So this is the graph by plotting the values, and by calculating the readings we are using the formula as a V1 N1 equal to V2. By calculating this N2 we are finding this volume of HCl solution and normality of sodium hydroxide solution, and last one is we are converting this volume of sodium hydroxide and the normality of HCl. So we are going to identify the values of N2 equal to V1 N1 by V2. So by using these two subtract we can get this N2 value, that is normality of HCl. So by both the values, the strength of HCl and the volume of sodium hydroxide can be calculated. So by using this we can identify this the HCl solution of meter. Thank you.